Hey guys, Art Lembo here again, and I just wanted to give you an update on some of what we've been doing with performing high performance computing with ArcGIS and the introduction of parallel processing through NVIDIA's Compute Unified Device architecture. Things may run a little bit slower because I have the screen recording device on, but you get the idea. We actually built a tool now for doing CUDA analysis. So in this case, I'm going to include Howard float file. So right now we're only reading float files, and we'll put the output into, let's go into floats and output, and we'll call it, actually we'll just leave it there because right now we just assign it to an output directory. And then the output name, we'll call it how for Howard, and we can perform a number of different functions. So whether we perform terrain ruggedness index, slope, aspect, min, max, mean, or range. Turn it off just for speed's sake. Actually, you know what? I'm going to do it differently. We'll do slope and aspect in this case, and then we'll hit OK. And now it's beginning to run, and we're running it over 4 different kernels because of the actual size of the data. And we'll let this run. I'm going to turn the video recording off for a moment, and we'll be right back. Okay, we're back now. That finished, and it took 39 seconds to complete it. And I'm going to bring that back in. So now what we'll do is actually run slope on Howard County again. Now this is an actual raster data set where before I used the float file, but we're just going to run this. And again, I'll turn the video off so we can see the time when we're done. And we'll let this run. And we're back, and you can see that that took 1 minute to do. So I'll close this off. So here are some results that we had. We ran it for a number of different processes in terms of number of pixels. So we have 3 billion pixels over here, all the way down to very few pixels that we have. So as you look, you can see that the CUDA version is significantly faster. We have some little anomalies. This is for slope. Here's our max value, so using max. And this is one where we ran, in this case, slope, aspect, min, max, mean, range, and terrain ruggedness. Actually, we didn't do the terrain ruggedness for this one. So as we began to layer them on top of each other, you can see the differences. And if you look at the scale, you can see here we're dealing with a value that gets into under 400 seconds compared to a value that is up over 1200 seconds. So quite a bit of an improvement. And if you look at just slope, for instance, you can see for Oxford, for instance, we went from 0.28 seconds to about 7 seconds in ArcGIS. So that was almost a 25-time improvement. For Allegheny East, we have almost an 8-time improvement. Again, for Baltimore County, we have about an 8.5-time improvement. When we get to Howard County, in this case, we have about a 5-time improvement. And then this one, Annapolis area, we have about an 8-time improvement again, and you can see the rest. So then down to Worcester County, which has 3 billion pixels, we're only seeing about a 3.5-time improvement. So we're trying to get a better handle as to why that's occurring. The other thing we're not quite certain of as we look at this is we ran these and took the average. So for instance, in Queen Anne's County, the very first time we ran it in ArcGIS, it took 1500 seconds. Then the rest of the times we were down around 153 seconds. So there's some kind of a hit that we're taking on this first run that we're not entirely sure about. Here 190, then went down to 142, 1300 down to 145. Howard County 748 seconds compared to 83. The CUDA version also has a little bit of a hit, so we're at 42 here, and then down in the 30s and some in the 20s. So some of that might be noise, but this is such a large change. I'd be interested in knowing why you think it performed so much slower the first time we ran slope on the actual test. And finally, I just want to look at this one where we did slope plus the aspect. If you notice, when we first ran it with CUDA, it took about 0.28 seconds to do slope. Aspect took about 0.25 seconds. But when we did slope and aspect one after the other, it was done 0.38 seconds. With ArcGIS, we went from 6 seconds and about 6 seconds here, 7 seconds and 6 seconds, and that wound up taking 12 seconds. This was really interesting because what we found was most of the time we're spent processing is getting the pixels onto the video card. Once we get a chunk of pixels on the video card, then we have the 500 streams to perform the analysis. So what we would do is we'd grab a chunk of pixels, put it on the video card, then run the slope on that chunk of pixels, then run the aspect on that chunk of pixels, write it out, then we dive back in and grab another chunk. So we're doing one copy routine, but computing two analytics, slope and aspect. So another interesting way of using the GPU is once you get the data on the card, that's when you start doing as many processes as you can. It costs us very little to do slope or aspect, or even here min, max, and mean. It costs very little to do those tasks once we have the data on the card. So for example, for min, max, well, even for this one, we're seeing probably a 30-time improvement, which is really good. We're not seeing as much as we move down further. In this case, running slope and aspect with ArcGIS, we're seeing about a 4-time improvement. So for us, the next frontier is really coming up with better ways of getting the data onto the GPU. Well, first off the disk, into computer memory, then into CUDA memory on the card, and then performing the analytics. So that's the next thing we're really going to learn is some of the I/O things, and I'll fill you in on what we do next. Have a good day.